Friends, welcome back to my YouTube channel. I am going to launch a new series of video lectures in which I will discuss previous year questions and their solutions of thermodynamics. And the questions which have been asked over the last 30 years in both mechanical engineering and also in XC, that is engineering sciences. Thermodynamics is one of the subjects in XC. So all those questions will be covered and detailed discussions will be there. Each and every question will be discussed in detail. So chapter wise the lectures will be delivered, and in the first lecture I am going to discuss about the thermodynamic systems and processes. That's the first chapter. Before starting, I must say one thing to all of you. Please do subscribe to this channel and of course like it and share it to your friends. Let's get started. So the first question is like this. An insulated rigid vessel contains a mixture of fuel and air. The mixture is ignited by a minute spark. The contents of the vessel experience, and options are increase in temperature, pressure and energy, decrease in temperature, pressure and energy. Option C is increase in temperature and pressure but no change in energy, increase in temperature and pressure but decrease in energy. So basically we have this question is related to the concept of system. What is a system? And the first law equation for a closed system. In fact, insulated means it's a closed system, and rigid vessel, insulated and rigid vessel, it contains a mixture of fuel and air, and the mixture is ignited. That means when it is ignited means a high temperature is generated around high temperature of, suppose inside this fuel and air is there, fuel and air, and once the mixture is ignited means a temperature of around 2000 degrees Celsius is produced, and of course pressure is also increased. Ignited means the combustion process is started. Once the combustion process is started means there will be burning. Burning means chemical energy will be converted into heat energy. In every fuel there is chemical energy, so there will be some energy conversions. So that heat will go to increase the temperature of the fluid. In fact, fuel and air mixture can be approximated as an ideal gas. Of course, the properties will be different insofar as the fuel and air mixture is concerned, and the properties will be different from that of pure air. Air is assumed as an ideal gas, but with some assumptions, fuel and air may be approximated as a mixture of ideal gases. Of course, there will be some deviations which you will study in IC engine, internal combustion engine. But assuming that this is a mixture of ideal gases, when heat is produced due to conversion of chemical energy, and since it is insulated, the equation for insulated means no heat can leave the system, neither heat can leave the system nor can heat enter the system, because this is an insulated. First word is insulated. These are keywords: insulated and rigid. And rigid means, the most important equation, first law equation is Q is equal to delta E plus W. This is applicable for any closed system. And of course you can see here there is no mass interaction taking place. Fuel and air mixture is contained inside this rigid vessel. So it can be also considered as a closed system. Nothing enters into the, once the process is started, nothing enters into this vessel, rigid vessel. So that's why this is insulated, means this is the first law equation for any closed system undergoing any process. This is the equation. We know that Q is 0 because this is insulated, and W is also 0 because this is a rigid vessel. No change in volume will be there. Rigid means volume will remain constant. So whatever heat is produced, it will not push the boundary, but no boundary work will be there since it is a rigid vessel. This is a rigid vessel. So these two terms are 0. Obviously delta E will be there. So delta Q is equal to delta E plus W. If both are 0, then delta E. Now this equation, this is the equation, and if these terms are 0, so delta E is going to be 0 or not? डेल्टा ई तो 0 होगा, क्योंकि ये है हमारा इक्वेशन, फर्स्ट लॉ इक्वेशन फॉर ए क्लोज सिस्टम अंडरगोइंग एनी प्रोसेस. Q is equal to delta E. Delta E मतलब change in total energy of the system, which contains three terms. One is K, kinetic energy, potential energy, and molecular internal energy. And if these two terms are 0, Q and W are 0, then delta E is obviously 0. So delta E is equal to 0 means E final is equal to E initial. So energy of this system before the process has occurred, before the spark has taken place, before the ignition has taken place, is equal to energy after the ignition has taken place. Change 0 matlab, delta E 0 matlab E is equal to constant. In other words, I can say E equal to constant. So energy is equal to constant. And among these given options, you see increase in temperature, pressure will obviously be there. Once the chemical energy is converted into heat energy, temperature will increase, and pressure will also increase. For an ideal gas, PV is equal to MRT. PV is equal to MRT. When temperature increases in both these mass and R, characteristic gas constant is constant. These two terms are constant. Once heat is given, means once spark takes place, means high temperature around 2000 degrees Celsius is produced, means this right hand side increases, temperature increases. Once chemical energy is converted into heat energy, means temperature increases, but the volume remains constant. So that means pressure has to increase. If this right hand side increases, means volume तो बढ़ेगा नहीं, क्योंकि ये rigid vessel है, तो pressure will obviously increase. So in this case, both pressure and temperature of the fuel and air mixture increase if any kind of sparking takes place. So but energy change नहीं होगा, क्योंकि ये delta E equal to 0. So among the given options, the correct option will be increase in temperature and pressure but no change in energy. So option C will be the correct answer. टेम्परेचर प्रेशर बढ़ेगा लेकिन एनर्जी में कुछ चेंज नहीं होगा, कुछ चेंजेस नहीं आएगा. ये 1993 में पूछा गया था. सो सेकेंड क्वेश्चन, दैट इज द डेफिनेशन ऑफ 1 Kelvin as per the internationally accepted temperature scale. Definition of 1 Kelvin as per the internationally accepted temperature scale is 1 divide, options are like this: 1 upon 100th the difference between normal boiling point and normal freezing point of water, 1 upon 273.15 the normal freezing point of water, and option C is 100 times the difference between the triple point of water and normal freezing point of water, and option D is 1 by 273.16 of the triple point of water. You see, originally the reference temperature which was chosen for Kelvin scale. You know Kelvin scale है ना, जो 273.5 ऐड करते हैं, 0 डिग्री सेल्सियस इज इक्वल टू 273.15 प्लस 0 केल्विन, that is 273.15 केल्विन. ये ओरिजिनली जब द रेफरेंस टेम्परेचर was chosen for Kelvin scale, it was 273.15 Kelvin, and which corresponds to ice point. So ice point, what is ice point? Ice point is nothing but the temperature. Ice point is the temperature. Ice point is the temperature at which ice melts. You know that ice melts into water at a constant temperature, and also water freezes into ice at that same temperature. That is called freezing point. So temperature at which ice melts into water and water freezes into ice under standard atmospheric conditions. Under standard atmospheric conditions. We know that 0 डिग्री में तो आइस मेल्ट करता है under standard conditions. If pressure temperature will vary, then it may vary, but under standard conditions ice melts into water at 0 degrees Celsius on being supplied some latent heat of fusion, and the reverse process also takes place. On removing some heat, water also freezes into ice at the same temperature. So that ice point, that is 0 degrees Celsius, was originally 0 degrees Celsius, which correspond to 273.15 Kelvin, was originally chosen as the reference point. But it was changed in the 1954 General Conference on weights and measures, and instead of a ice point, triple point of water was chosen to be the reference point. Earlier to that, ice point was the reference point. Ice point is nothing but, in terms of Celsius scale, it is 0 degrees Celsius, and in Kelvin scale it is 273.15 Kelvin. 273.15 Kelvin. But in 1954 what happened? That was changed. वो change हो गया. जो triple point of water became the reference point. Triple, now the new reference point was the triple point of water. Triple point of water. What is this triple point? You will study in properties of pure substance. This is triple point of water is triple point of water is a state at which three phases of water. What are three phases of water? तुमको मालूम है. सॉलिड स्टेट में ये आइस है, लिक्विड में तो वाटर, लिक्विड वाटर, एंड वेपर फेज में वाटर वेपर है. सो थ्री phases of water coexist in equilibrium. coexist in equilibrium. So ये जो ट्रिपल पॉइंट को रेफरेंस पॉइंट लिया गया 1954 में जनरल कॉन्फ्रेंस ऑन वेट्स एंड मेजर्स में, वो है 273.16 Kelvin, and in terms of at the same conference also Celsius scale was redefined, and this triple point corresponds to 0.01 degrees Celsius. So 0.01 degree Celsius on Celsius scale corresponds to 273.16 Kelvin. So that was designated as the new reference point. So from that time onwards, this triple point has been considered to be the reference point, that is 273.16 Kelvin. That means 1 Kelvin will be 1 upon 273.16, the triple point of water. If triple point of water is 273, if triple point of water is 273.16 Kelvin or 0.01 degree Celsius, then 1 Kelvin will obviously be 1 upon 273.16 of triple point of water or not. It's obvious, because if triple point of water is 273.16 Kelvin, then 1 Kelvin will be 1 upon 273.16 of the triple point of water. And on this, in the same conference also, the steam point was experimentally found to be, steam point means water changes into water vapor, or liquid water and water vapor will remain in equilibrium under standard atmospheric condition at 100 degrees Celsius. So steam point was also established at that conference. So our correct option will be the option D, 1 upon 273.16 of the triple point of water after 1954. But before 1954, it would have been the answer, 1 by 273.15 of normal freezing point of water. पहले ये था रेफरेंस पॉइंट, फ्रीजिंग पॉइंट ऑफ वाटर, प्रायर टू 1954. अब उस कॉन्फ्रेंस के बाद ट्रिपल पॉइंट ऑफ वाटर जब रेफरेंस पॉइंट बन गया, जो कि 273.16 केल्विन है, तो ऑब्वियसली 1 केल्विन विल बी, सो 1 केल्विन विल बी 1 अपन 273.16. अभी तक कुछ चेंजेस नहीं हुआ है, तो हमारा आंसर ऑब्वियसली ऑप्शन डी होगा. 1954 के बाद कुछ चेंजेस नहीं आया है. So next question is question number 3. The specific heat of an ideal gas depend upon its, the specific heat of an ideal gas, the specific heat, ये जो क्वेश्चन है, second question was asked in the year 1994 and it carries 1 mark. Then third question is, the specific heats of an ideal gas depend upon its temperature, pressure, volume, molecular weight and structure. Out of these 4, which will be the correct answer? And it was asked in the year 1996 and it carries 1 mark also. So first we must know that the specific heat of an ideal gas. We know that there are 2 types of specific heats for ideal gas. One is Cp and Cv. Cp stands for specific heat at constant pressure. Cv stands for specific heat at constant volume. ये किस पे डिपेंड करता है? We know that for any particular ideal gas, Cp minus Cv is a characteristic gas constant, which varies from gas to gas, and this R is nothing but R bar divided by molecular weight of that particular gas. So characteristic gas constant varies from gas to gas, but this universal gas constant does not vary. It is constant, that is 8.314 kilojoule per kg mole Kelvin. So Cp and Cv are different for different ideal gases, and that is difference of Cp minus Cv is R. And we know that ratio of specific heats of ideal gas is also a constant that is denoted by gamma, and sometimes it is also denoted by k also. Suppose it is, we will take it to be gamma, जैसे कि एयर के लिए वो 1.4 है. So Cp by Cb is gamma. From these relations, what we can find is, from this is the relation, Cp minus Cb is equal to R. So if I divide both sides by gamma, sorry, if I divide both sides by Cb, Cp by Cb minus Cb by Cb is equal to R upon Cb. So यहाँ से क्या आता है, Cp by Cb is nothing but gamma minus 1 is equal to R by Cb. यहाँ से क्या आता है, Cb is equal to R divided by gamma minus 1, and we know that Cp by Cb is equal to gamma. From that, Cp is equal to Cb multiplied by gamma. If Cb is equal to R divided by gamma minus 1, then obviously Cp will be Cb multiplied by gamma, मतलब R gamma divided by gamma minus 1. So यहाँ से हम क्या देख रहे हैं, Cp और Cb depend only upon R and gamma and nothing else. Cp and Cb depend only upon R and gamma. Cp specific heat at constant pressure, Cb specific heat at constant volume. ये दोनों सिर्फ R कैरेक्टरिस्टिक गैस कांस्टेंट पे डिपेंड कर रहा है और गामा पे डिपेंड कर रहा है. लेकिन R जो है कैरेक्टरिस्टिक गैस कांस्टेंट, वो है हमारा क्या, दिस इज यूनिवर्सल गैस कांस्टेंट डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ द गैस. जैसे कि मैं सपोज कैरेक्टरिस्टिक गैस कांस्टेंट ऑफ एयर निकालने के लिए R बार डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ एयर, जैसे कि कार्बन डाइऑक्साइड के लिए RCO2 निकालने के लिए 8.314 डिवाइडेड बाय 44, ऐसे मॉलिक्यूलर वेट लेके हमको डिवाइड करना है. सो ऑब्वियसली कैरेक्टरिस्टिक गैस कांस्टेंट इज रिलेटेड टू मॉलिक्यूलर वेट. कैरेक्टरिस्टिक गैस कांस्टेंट इज रिलेटेड टू मॉलिक्यूलर वेट ऑफ गैस. लेकिन according to kinetic theory of gases, this gamma ratio of specific heat is related to atomic structure. ये एटॉमिक स्ट्रक्चर पे डिपेंड करता है, क्योंकि मोनोएटॉमिक गैस के लिए गामा का वैल्यू होता है 5/3, डाईएटॉमिक गैस के लिए गामा का वैल्यू होता है 7/5, एंड पॉलीएटॉमिक गैस के लिए ये होता है 4/3. And in fact the minimum value of gamma is 1 minimum value, and maximum value जो गामा का होता है 1.67. सो मतलब ये मोनोएटॉमिक, जब कोई मॉलिक्यूल एक एटम को लेके होता है उसको मोनोएटॉमिक बोलते हैं. मतलब ये जो गामा है ये तो मॉलिक्यूलर स्ट्रक्चर पे डिपेंड कर रहा है, एटॉमिक स्ट्रक्चर पे डिपेंड कर रहा है, और जो R है वो तो मॉलिक्यूलर वेट, क्योंकि ये तो कांस्टेंट है, यूनिवर्सल गैस कांस्टेंट, दैट इज 8.3143. ये कांस्टेंट है, मतलब इसका कोई इफेक्ट नहीं रहेगा. कैरेक्टरिस्टिक गैस कांस्टेंट डिपेंड्स ओनली अपॉन द मॉलिक्यूलर वेट ऑफ गैस, एंड गामा डिपेंड्स अपॉन द मॉलिक्यूलर स्ट्रक्चर ऑफ द और एटॉमिक स्ट्रक्चर ऑफ द गैस. इसका मतलब तो स्पेसिफिक हीट ऑफ एन आइडिया, एंड वी हैव फाउंड दैट this Cp and Cb, Cp is gamma R divided by gamma minus 1, Cb is R divided by gamma minus 1, where R is the characteristic gas constant and gamma is the ratio of specific heats of that particular ideal gas, and R is also constant for a ideal gas. So किसी भी आइडियल गैस का जो स्पेसिफिक हीट है वो टेम्परेचर और प्रेशर पे डिपेंड नहीं करता है, वॉल्यूम पे भी डिपेंड नहीं करता है obviously. So it depends upon molecular weight and structure. So option D will be the correct answer, molecular weight and structure. So next question जो है, an isolated thermodynamic system executes a process, choose the correct statements from the following. No heat is transferred, no work is done, no mass flow across the boundary of the system, and option D is no chemical reaction takes place within the system. वो 1999 में 2 मार्क्स के लिए क्वेश्चन पूछा गया था. So which of these, choose the correct statement or statements. Maybe one out of these 4 statements is correct हो सकता है, otherwise more than one may be correct. There is no such restriction that only one will be correct in this particular question. Either one statement out of these 4 may be correct, or more than one may be correct. Maybe 2 or maybe 3 or all may be correct also. So all those events possibilities are there. So we must discuss what happens if there is an isolated thermodynamic system. We know that there are 3 types of systems. One is closed system. This is closed system. क्लोज सिस्टम में क्या होता है, ओनली हीट इंटरेक्शन, एनर्जी इंटरेक्शन इज पॉसिबल, बट नो मास इंटरेक्शन इज पॉसिबल. मास आ नहीं सकता है, भी जा नहीं सकता है. ओनली हीट इंटरेक्शन कैन टेक प्लेस इन द फॉर्म ऑफ हीट और वर्क. हीट और वर्क आर द बाउंड्री फेनोमेनन, वी हैव ऑलरेडी स्टडीड दैट. एंड क्लोज सिस्टम में क्या होता है, ओनली एनर्जी इंटरेक्शन इज पॉसिबल बट नो मास इंटरेक्शन इज पॉसिबल. And in case of open system, both mass and energy interactions are possible. We have already discussed that. And in isolated system में क्या होता है, neither energy nor mass interaction is there. वो system is completely isolated from the surrounding. Isolated और insulated में difference है. Insulated मतलब हीट ट्रांसफ़र नहीं हो सकता है, लेकिन वर्क फ्लो हो सकता है, वर्क ट्रांसफ़र हो सकता है. लेकिन आइसोलेटेड मतलब कुछ भी एनर्जी इंटरेक्शन तो पॉसिबल नहीं है, उसके अलावा मास इंटरेक्शन इज ऑल्सो नॉट पॉसिबल. देर कैन नाइदर बी मास इंटरेक्शन नॉर एनर्जी इंटरेक्शन बिटवीन द सिस्टम एंड सराउंडिंग, एंड दैट इज कॉल्ड द आइसोलेटेड सिस्टम. सो कुछ भी अंदर और बाहर के बीच में कुछ भी इंटरेक्शन इज पॉसिबल नहीं है. सो ऑब्वियसली नो हीट इज ट्रांसपोर्ट, ये तो सही है. नो हीट तो आ नहीं सकता है या जा नहीं सकता है. नो वर्क इज डन, ये भी पॉसिबल नहीं है. वर्क इंटरेक्शन और हीट कोई किसी तरह की एनर्जी इंटरेक्शन इज नॉट देयर, इज नॉट पॉसिबल. नो मास फ्लोज अक्रॉस द बाउंड्री ऑफ द सिस्टम, मास भी बाउंड्री से नहीं आ सकता है. सपोज दिस इज द बाउंड्री, मास जितना मास होगा वो फिक्स्ड रहेगा. इसमें बोथ मास एंड एनर्जी ऑफ द सिस्टम रिमेन कांस्टेंट. Here only mass remain constant, energy may vary, energy of this system may vary. But isolated system में क्या होता है, both mass and energy of this system remain constant. So these 3 options are correct. Mass flows तो नहीं होगा across the boundary, mass तो जा नहीं सकता है, आ नहीं सकता है. लेकिन ये जो 4th ऑप्शन है, no chemical reaction takes place within the system, ये गलत है. केमिकल रिएक्शन हो सकता है, क्योंकि अगर कुछ केमिकल रिएक्शन अंदर होगा तो उसमें कुछ दिक्कत नहीं है, वो दैट विल बी इनसाइड दिस. जैसे कि हम फास्ट क्वेश्चन सॉल्व कर रहे थे, जब इग्निशन हुआ वो तो अंदर में प्रेशर टेम्परेचर को बढ़ा दिया, लेकिन इंसुलेटेड होने के कारण और रिजिड होने के कारण एनर्जी कांस्टेंट रहा. लेकिन यहाँ क्या हो रहा है, वहाँ भी कुछ इंसुलेटेड होने के कारण हीट इंटरेक्शन नहीं हो सकता, एंड रिजिड होने के कारण वर्क इंटरेक्शन तो हो नहीं सका यहाँ. एंड देयर वाज गिवन इन दैट क्वेश्चन दैट वाज गिवन दैट नो मास interaction is there, but here it is a isolated case. It is not possible for any mass transfer to mass interaction to take place. So अगर कोई केमिकल रिएक्शन हो रहा है इसका अंदर, तो एक फर्म से दूसरे फर्म को कन्वर्ट हो जाएगा. वो एनर्जी ऑफ द सिस्टम इनसाइड में रह जाएगा, वो कन्वर्सन हो सकता है, लेकिन बाहर से कुछ इंटरेक्शन इज नॉट पॉसिबल. इनसाइड में अगर कुछ केमिकल रिएक्शन होगा तो हो सकता है, वो बाहर नहीं आएगा, कुछ एनर्जी बाहर नहीं आएगा, और एनर्जी बाहर से अंदर कुछ भी एनर्जी नहीं जाएगा. सो मतलब केमिकल रिएक्शन होने में कुछ दिक्कत नहीं है. नो केमिकल रिएक्शन टेक्स प्लेस विद इन द सिस्टम, दैट इज नॉट राइट. सो केमिकल रिएक्शन हो सकता है. सो ओनली A, B and C are correct options. So D is not the correct options. So ये सही है, ये सही है. So A, B and C are the correct answers. So that's all.